The third speaker is Mr. Marini, who is the CEO, Country Manager Italy and Regional Manager Mediterranean of ABB Italy. He holds a Master in Business Administration at Università Bocconi in Milan, although he has made the position, he's from Venice. He has had a long career in ABB since 1991, where he joined ABB, and currently he has also, before the current position, he has held several positions in several countries, but namely in Switzerland, where from 2006 to 2009, he was Group Senior Vice President, Global Head of Front-End Sales Power Product Division at ABB headquarters in Zurich. Now, Mr. Marini is going to talk about the influence of automation in the increase of productivity and competitiveness. We've been hearing something about it this morning, but I'm sure we will learn many other things now. The floor is yours.
Thank you. It's a bit difficult to start talking after Siemens, but I'll try. So first of all, I'll try to make a point with my 20 minutes prelusion. You see, we have, in this country, in Italy, we have 12 major factories. And what I'll try to show you with a little video in a few seconds is what many of the things we said today are, to a large extent, applied. Applied because it's an applied choice. And what we saw in my predecessor, I mean, Mr. Gattegno said manufacturing close at heart. Well, it's very close to my heart for sure. And we saw also the rising costs of engineering and manufacturing in typically sourcing countries like India because of the high exchange rate of the rupees, for instance, or China because of the increased standards of living. I mean, the costs are actually rising. So to base a global strategy only on low cost of labor, it's a losing proposition by definition. So having this in mind and having a certain knowledge of what we do in terms of automation, we wanted to apply on our own factories the concepts we would like to sell to our customers. So I'll try to make the point today that automation pays off, is a fundamental element to keep and to increase our own competitivity. And I'll start with a little video, if you don't mind, just to show you a real example. So forget about the red logo, but concentrate on the things you see, just to see how technology is actually applied on a modern manufacturing line.
We're in the ABB medium voltage plant in Dalmine, Italy. There are 3 production units: apparatus, circuit breakers, disconnectors and contactors, switch gears for primary and secondary distribution, servicing for plant maintenance, spare part management and retrofitting of old products. Today we're going to talk about industrial automation in production processes. Since 2008, our production units have structurally applied the concepts and techniques of lean production. We went to Japan to see firsthand the factories that apply the Toyota production system. We returned to Dalmine and got started, creating what we call the Dalmine Lean Way. The Dalmine Lean Way can be visualized as a building consisting of 2 pillars, representing innovation in the production process. On the one hand, the just-in-time approach allows us to produce a tight flow, synchronized with the market. And on the other, the Jidoka principle guarantees the quality of what we produce. The base, representing the knowledge necessary to support the 2 pillars of innovation. The roof, representing the goals to be achieved in terms of production cost. Let us now focus specifically on the right-hand pillar. Jidoka, a Japanese word, can be translated into English as autonomation, which means automation with the active presence of man. To apply Jidoka means using machines that shut down at the slightest hint of a problem, but which are attended by trained operators who can intervene, identify the problem, rectify it, and restart production. Another fundamental result obtained through automation is objectification, a requirement now demanded by all our customers. Automation gives certainty to the actions undertaken and ensures the quality certification of the assembly and testing phases. In addition, the application of automation requires the systemization of processes. Our experience in Dalmina has taught us not to assume that the processes we think we have under control can be left alone.
Here at Dalmina, just where have we applied automation on the equipment and switchgear lines? To the handling systems, because they improve return on investment and because they ensure there are no errors in production flow. To the test phases, to guarantee quality and objectification. Control operations are performed automatically on 100% of the parts in the various process phases and on the finished product through a visual inspection performed by an ABB robot. To the repetitive and quality critical assembly phases, such as screw fastening, ensuring the correct sequences and the correct tightening torques. To the non-repetitive assembly phases, grouped together and performed by an ABB robot with a significant reduction in costs. The assembly phases that are critical from the ergonomics and safety standpoint, such as the handling of bulky components. And finally, to information management. Today, the plant is paperless, thanks to the Manufacturing Execution System, MES.
However, all of the above merely represents a first, albeit very important, step in the process of industrial automation. We are developing new products with our project team, now enhanced by individuals specialized in industrial automation. Design for automation will be the new frontier of the Dalmina Lean Way.
Thank you. Right, so this investments, which started in 2006 on this particular unit, brought tangible results. I mean, as I said, there's a lot. First of all, there's a lot of Japanese terminology because that were at the very beginning we thought we should look for inspiration. It did pay out because at the end of the day, you're talking of different product lines, which you saw an average reduction of throughput time in the range of 50%. I mean, with double capacity. And that's clearly an advantage. Advantage which is in the not only on the traditional health and safety or quality or robustness of the process on the output, but as I said, it actually brought money. So this unit, along with the other 11 units that we have in the country, is actually showing us where we can actually push today's technology. And if you think which are the key elements that drive competitiveness, probably it's quality, price, production flexibility, and product diversification. I'd say that we cover most of them in what you saw in the little video. So my point is automation actually pays off in terms of competitivity, increases competitivity. Now, people. This is just a slide, it's a caption for one specific topic, the collaboration of people and machine. It was mentioned in a previous speech that there's a growing tendency of not really replacing one with the other, but having the two working nicely together. And when our last slide, I'll come to that point. Big data. Big data is an issue. I mean, that's why you see many ICT companies very much interested in what's happening in the domain of smart grids or the evolution of the digitalization of traditional components. And if you think a fairly simple machine like, I don't know, a power transformer in the past was simply a black box in a control room. Today, with the possibility of having digital accessories to a power transformer, it basically doubles or trebles the amount of information you can actually get from that very simple and static machine. So this is also, increasing the amount of data which you can actually have to process to obtain the overall control of the system. So as I said, it's an integrated system, and the example I'm showing here just shows that all the different bits and pieces of the production process come together. The final bullet, I mean, just for you to reflect on this quite straightforward points. I mean, where we are today, where we're moving in the future, from manual interactions to automated workflow. But the real interesting one is the final bit, the final bullet. I mean, previously you could say that you were organizing your manufacturing on predictive models, on records, and working on historical series, whatever. I mean, today, what is really striking is that the decisions are made exactly in real-time information. And this is, frankly, the most, I would say, stunning innovation which we could actually talk about. I mean, this is an example of the typical information of an operator in a control room in a modern power plant he has today available. I mean, it's like a video game. He's got all the different information at hand. He's got personalized messages. He's got record of all the documentation he may need to consult. He's got visual monitoring system and condition monitoring, all the alarm list. This is, again, it's here today already. Augmented reality is also something you want to consider in the future. So far, our experience is mostly related to the mobile operators and service personnel that basically would travel and using quick read codes would actually access to a huge amount of data. And possibly we have other applications, but so far this is where we have practically pushed our own research team to work for. Coming to trends, this is just a summary. I mean, I thought I made my point at the beginning to show you that many things are available already today. These are probably where the major trends are in terms of automation. I mean, under the processing communication, faster, smaller, wireless for sure. 3D printing, I think it was probably hinted to in the previous discussion. So far, we're using 3D printing mainly for quick prototyping. I mean, we know we have robot-based application for architectural design studies that basically want to have a quick, 3D printed prototype of what's going to be built ultimately. We have it for our own, for instance, molded case circuit breaker. I mean, in Bergamo, we have a brilliant solution for that. But again, we don't see that coming that quick when it comes to real industrial application. So our experience so far is very much limited to the quick prototyping. Actuators, for sure, plenty of them, consuming fewer energy and definitely much more precise. Sensor almost everywhere, and this is go back to the big data discussion we had before. So the critical issue today is really how to manage massive amount of information and make a use out of it. So the traditional manufacturing execution system that you see scattered around in our units, for instance, probably are will be obsolete to a large extent, because they're sort of traditionally based, but I'm not sure they're actually ready to manage the huge amount of terabytes that we saw in the previous presentation. And again, in principle, operations are going to be more intuitive. I mean, if I think of our own robots, I mean, the tricky part is to make a very complicated programming simple for the operators, maybe using an iPad or something, or a tablet. That's a real challenge, I can tell you. I mean, this is where we're going to be spending big money and where the future of technology will probably go. As a closing remark, it's again the interaction between man and machine. This is a real thing. This is a double arm robot we launched we actually promoted in North America a few weeks ago. And this is actually, it's real. I mean, you see the handle on top of it. It's really, you can actually carry it around. And this, to me, is quite interesting because it's integrating a number of things. I mean, sensors, visors. The programmable unit is incorporated into the body. And obviously, the payload is not huge by definition. But this is, we think, is going to be useful in in the startup phases where, particularly in the electronic industry or something, you don't want to pass to massive robotization of your factory, but you want to, in a sense, help the ramp up of the phase with a relatively agile and productive mean, without necessarily investing on fixed manufacturing, fixed robotic applications. This is to us is quite a revolution. Again, it's a single phase. You just plug it into the shop floor, and the beauty is that it works along with man. I mean, usually robots are fenced. It's quite heavy and complicated to prepare for a robotic application. This will be fairly straightforward, and we think this is probably the culprit, the utmost advanced solution we can think about when it comes to advanced automation and robotic application. So I would like to try to save some time for questions, if any. And I'd like to close my final remark saying that automation has been applied already heavily into our units, into many units, not necessarily ABB, a lot of units around the world. The trends we discussed about are quite clear. It's all about increased data. It's all about increased precision, wireless, lower consumption. And ultimately, we think that the cohabitation of man and machine is possible. And it's actually quite a fundamental part of the ramp-up phase of a large manufacturing like the one you have at my backs. So thank you very much for that. And just my final remark that man is still useful. And actually working along with a robot is something which is gratifying us at a bit, we're pushed towards a different limit and different level. So I thank you very much for your attention.
Thank you very much, Mr. Marini. We are happy to hear that despite the fact that automation pays off, man is still useful. Women too.